Good morning, students. Myself, Kaushik Ghosh, your physical science teacher. This video lesson is for class 10, and the chapter which we are going to discuss is Thermal Phenomena, Module 2. In the first module, you have seen that we have already discussed about few things like linear expansion, superficial expansion, and volume expansion. Now, in this second module, we will discuss about the thermal conduction. Let's You must be familiar with the fact that heat may be transferred from one place to another by three processes, and they are conduction, convection, and radiation. Now, in conduction process, heat passes along a substance from the hotter parts to the colder parts, or from hotter body to colder body when they are in contact, and without any transfer of material particles. For example, if one end of a long rod is held over a flame, you can feel the heat as the heat passes from the hot region to the cold region by the conduction process. Now, what is happening here, as you can see, the molecules which are present inside this material, they are actually not moving from one end to another end to carry the heat. Suppose the first molecule which faces the heat, and as you already know that the molecules are always in a state of random vibration. So this molecule takes the heat energy from this oven and starts vibrating with a larger magnitude. And during this vibration, this molecule passes the heat to the nearest molecule, that means this one. And like this, vibration goes on and the heat gets passed from one end to other end. And that is why the handles of few cooking utensils like saucepan or frying pan, they are provided with an insulating cover here in the handle, so that it will become easy for you to hold this handle and cook. Otherwise, what will happen when these utensils will get heated, the heat will pass from this hotter region to the colder region, that is the handles, and it will be difficult for us to hold the handle and cook. Remember one thing, different materials have different ability to conduct heat, okay, and you will get many more examples in our everyday life of this thermal conduction. Now we will discuss about thermal conductivity. So the transfer of heat energy by conduction occurs mainly due to the temperature difference between adjacent parts of a body. Now let us consider a rectangular solid bar whose length is L and area of cross section is A. And also the temperatures of two adjacent sides, let it be theta 2 and theta 1 respectively. And here theta 2 is greater than theta 1, means I am considering this to be hotter part and this to be colder part. So the heat passes from the left side to the right side. Now if Q be the quantity of heat conducted through the solid bar, then it is experimentally found that it is directly proportional to the area of cross section of the bar. Next, Q is proportional to the difference in temperature between its two ends. That is, Q is directly proportional to theta 2 minus theta 1. Q is also directly proportional to the time in which the quantity of heat passes through the slab. And Q is inversely proportional to the width of the conductor. That is, Q proportional to 1 by D. So if I combine all these four equations, what will I get? I'll get as Q directly proportional to A into theta 2 minus theta 1 into T divided by D. Now we all know that in order to remove this proportional sign, and if I want to give it an equal sign, I have to put one constant. So here is it, Q equals to K into A into theta 2 minus theta 1 into T divided by D, where K is the constant, proportionality constant, and it is known as actually thermal conductivity. It depends on the material. Now from this equation we can define K. See, if I take area as 1 meter square and the width as 1 meter and the temperature difference between two surfaces be 1 degree centigrade and the time is 1 second, Then what we are getting from this equation? Q is equal to K into, see these are all 1. That means Q equals to K. So Q is numerically equal to K. So we can define here the thermal conductivity of a material is the amount of heat which passes normally in 1 second through the opposite faces of a unit cube when the difference in temperature between the two opposite faces is 1 degree centigrade. Now my dear students, as I have said here, unit cube, that means length, breadth and height all are 1. That's why you are getting a volume of 1 meter cube, you can see here. Now we will discuss the units of thermal conductivity. So here's the equation. Now from this equation we are getting K as equals to this. Now my dear students, here as you can see, one term is there, A means area, length into breadth, and there is a term here D, that is the breadth. So breadth cancels out. What remains here? Only length. So we can write K is equals to Q divided by length into temperature difference into time. So from this equation we are getting the unit of thermal conductivity. Now in SI system of unit of heat is joule, length is meter, temperature difference is Kelvin, and time is second. So we are getting the unit as joule per meter Kelvin second. Now joule per second means watt. So in another way we can write the unit as watt per meter Kelvin. Similarly, in CGS system of unit, the unit comes as calorie per centimeter degree centigrade second. The thermal conductivity of natural diamond is very high. It is 2200 watt per meter Kelvin. That's why it's a very good conductor of heat. Normally, the materials which are having a higher value of thermal conductivity are good conductors of heat. Thermal conductivity of silver is quite lower. It is 406 watt per meter Kelvin, and that is of copper is 385 watt per meter Kelvin. Another fact, this value of thermal conductivity depends on the temperature. Means if the temperature difference between two adjacent sides is not very large, then the value of thermal conductivity remains almost constant. Now we will discuss about thermal resistivity. The reciprocal of thermal conductivity is known as thermal resistivity. Now from this equation you can see, if I want to find out the rate of heat flow, that is amount of heat flowing divided by time, Q by T, we are getting this equation theta 2 minus theta 1 divided by D by Ka. Now this expression is very much similar to the expression of current flowing through a conductor, which is given by the Ohm's law. Now the mathematical form of Ohm's law is this: V2 minus V1 is equals to I into R, where V2 minus V1 is the potential difference between the two ends of a conductor, I is the amount of current flowing through it, and R is the resistance of the conductor. Now the resistance of a conductor can be written as rho into L by A, where rho is the specific resistance or resistivity of that conductor, length is the here L, that is a conductor, and area of conductor is A. So this equation we can write as I equals to V2 minus V1 divided by R, and in place of R we can simply put rho into L by A. So we are getting I equals to V2 minus V1 divided by rho into L by A. Now if I compare these two equations 1 and 2, we can write this rho into L by A equivalent to D by Ka. That means this is known as thermal resistance, D by K into A. That is the width divided by thermal conductivity into area of cross section. And this rho into L by A, it is known as electrical resistance. So thermal resistivity will be written as 1 divided by K. Well, my dear students, there are few questions from this chapter whose answers need to be written in your classwork copy. The first question is, what is the SI unit of linear expansion? Second, what is the SI unit of thermal conductivity? Question number 3, Write the ratio of three different coefficients of expansion. Number 4, what do you mean by apparent expansion of liquid? Number 5, why there is a gap at regular interval between the rail lines? Number 6, starting from the definition of volume expansion, arrive at Charles' law. Number 7, what is thermal resistance? And number 8, discuss about the factors on which the quantity of heat conducted through a solid bore depends. Write the answers with the questions in your classwork copies. I'll correct the answers when the school gets opened. Okay, this is for the day. I hope this video lesson will help you in learning this chapter. Go through the textbook twice or thrice and try to understand what is given. I'll be back soon with the new chapter. Till the time, stay home, stay safe. Thank you.